The question, you have got a deck of cards with two colors, red and black. Okay, there are four suits obviously. You've got your spades, your hearts, your clubs, and your diamonds. Okay, so a contingency table was put together because of the two different colors and also the two categories in terms of spades and other types of cards. Okay, so when you have got a contingency table, first thing, it's important for you to know that this number here, where the totals of the horizontal totals and the vertical totals intersect, it will be your NS. But now, by now, I expect everybody to understand or to know what I mean by NS. That's the total in the sample space. Okay? So whenever you are doing calculations on the contingency table, especially the probabilities, first check if your NS is there. If it's not there, then you might need to calculate it. Okay, so let's just answer the question. Now the question says, determine the probability that a randomly selected card is black, right? So you just go to those cards that are black. Remember, if cards are black, they can be spades or they can also be clubs. Okay? So the total of the black ones is going to be, well, in this case here, it's going to be 26. So you just add the 13 plus 13, you get these 26 here. That's the total of all the black cards. Okay? So, to calculate that probability, it's going to be very straightforward. So, one is going to be P, black is going to be 26 over 52, which is a half. Okay, we just write it in simplest form. Now, as I said yesterday, I'm going to emphasize this. When you're calculating probabilities, if it's not specified that you must leave your answer as a percentage, it's not necessary. Okay? Unless it is specified rather, that's when you can convert to a percentage. If it's not specified, there is no need. You can leave your answer as a common fraction, or you can leave your answer as a decimal fraction. If it's not specified that you are supposed to leave your answer as a decimal fraction, there is no need to convert this half to 0.5 because a half and 0.5 are the same. Okay, so make sure you are aware of it. All right, and then number two, a spade. Now, if a card is a spade, it means, okay, in this case here, they just say a spade. How many spades are there? Huh? How many spades are there? It's going to be what? 30. Okay? Please take note. We're talking about spades only. Now, that's specific. That's more specific now. So, our spades are here. Those are our spades. Okay? So, P, the probability that the card is a spade probably that the card is a spade, it's going to be 13 over 52, which gives you a quarter. Okay? Then, let me move on to the next page. We want to overcrowd stuff. Okay. Right. Is there anybody who has got a question so far? Is there anybody who has got a question so far? Okay, if you don't have a question, then let's go. But then a card is black and it's also a spade. Now you have to go to the intersection now of spades. So if I draw a horizontal line from spades all the way up to black here, there is an intersection point. So that will be 13. That's a common point. So a card is black and is also a what? A spade. Okay? So the probability of number 2 and number 3 is going to be the same. For number 3, so P, D, so that will be 13 over 52, which is 40. Okay? Then black or a spade. Okay? Now, this one now, my suggestion for you to do this one, you can use the addition rule if you want. Okay? You can use the addition rule. But you can also find it directly from the contingency table. Remember what I said about the word or, it means what? Add. So what this means is you need to know how many cards are black. Right? So in total we have got what? 26. Then you also have cards that are spades. The total of the spades is what? It could have been 13 as well. So it's saying black or what? Spades. Right? So that would be, so that's number 4. So that would be P, black or spade. Okay? Now I can also use the addition rule. So to be the probability of all the black cards plus the probability of all the spades, then you subtract the what? The intersection, which I think will be much better. Okay? So this will be probability that the card is black plus the probability that the card is a spade. To avoid double counting, that's why we have to do this. To avoid what? Double counting. Minus the probability that the card is black and is also so that would be 26 over 52 plus the card that it is spade, 13 of them, so that would be 13 over 52. But please be aware that the spades, they are also black, isn't it? Right. So you can end up counting them twice. If you don't use the addition rule, if you just do it mentally, you can end up counting twice. So what's the intersection? So that is 13 over what? 52. So these two will give us 0. So we're left with what? 26 over 52. And that's a what? Are you following? I'm using a grade 10 formula, which is the addition rule, to answer that question. Yes? Yes. Okay. You can also write your answer as a quarter. But you see, if the question does not specify whether you should leave your answer to simplest form, if you write 13 over 52, it will be correct. If the question specifies that leave your answer in simplest form, then the best answer will be a quarter. Okay, but there is no need to convert to percentages. I'm emphasizing. Okay, no need. I always laugh when I see people writing the answers in 3 different ways that are the same. Okay. So some of us, we had the privilege of studying this up to university, so we have a better understanding of how to calculate probabilities. Okay, it's a great privilege. Right. Then number 5, red or a spade. Okay. I would just suggest that use the addition rule to avoid what? Double counting. Because you can easily make a mistake of counting twice, which is a very common thing. So the the probability of picking a red or a spade should be equal to the probability of picking a red plus the probability of picking a spade minus the probability of picking a red card and a spade. Okay. Then, that is the probability of picking a red card. That's 26 over what? 52. Okay, so this will be 26 over 52 plus the probability of hitting a spade, okay, is 13 over 52 minus, is there any intersection between spades and red? It's there, that is 0, this one here, that's the intersection. So we have got spades here, then we have got red, there's an intersection. Fortunately, you cannot pick a spade and also you pick it, and they need to be a red card, because we know that spades, they are what? They are black. You can't have a spade which is red. So the probability of picking a red card which is a spade, it has to be a 0. Which means, based on mutually exclusive events, complementary, independent, what would you say about picking a spade and a red card? What type of an event is that? Mutually exclusive. So they are mutually exclusive because they cannot take place at the same time. You can't pick a red card which is also a spade. It's not possible. Okay. So put 0 here. Then you put nicely. So we'll put 0. So that will give us 39 over 52, and we get 3 over 4. Okay. We're following that. Okay, let's move on to those questions. Now, sometimes when you are given a contingency table, you can be asked to prove that events are mutually exclusive and you are supposed to provide a motivation. Also, that events are independent and you're also supposed to provide a motivation. Okay? So these are common questions. Okay, let's start with the first one, number 2. We are still using the contingency table. Okay, we are still using the contingency table. So the question says, are the events card is red and card is spade mutually exclusive? And then it says motivates them. Okay, so let's prove that. We have already done it, but we are going to do it formally. Okay, so if they are mutually exclusive, the probability of picking a red card or a spade must be equal to the probability of picking a red card plus the probability of picking a spade. Okay? So let's check that the left hand side is equal to the right hand side. If it is, then we can conclude that therefore the two events are mutually exclusive. Okay, please, your justification there would be the fact that the left hand side will be equal to the what? To the right hand side, then you give the conclusion. If you decide to use the addition rule, you can also answer the question by using the addition rule as well, whereby the intersection will be what? The probability will be 0. So the probability of picking a red or a spade, okay, we've already found it. It's 3 over what? 3 over 4. We found this answer. Okay? The problem now comes if this answer is not correct. you are bound to have issues. And you might not be able to answer the question properly. So this is 3 over. That should be equal to. That should be equal to the probability of picking a red, which is a half. So that would be plus. This is what we put in the wrong place. So 3 over 4, picking a red, that's 26 over 52 plus. Probability of picking a spade, that's 13 over 52. So if you do the math, you get 3 quarters on both sides. Okay? Then it says therefore, the 2 events are mutually exclusive. Okay? If you use the addition rule, you have to specify that the probability of their intersection is 0. Okay? Please be aware that the same question can be done using the addition rule, but you have to specify that the probability of the intersection is what? Is 0. Okay. All right. Okay, let's carry on then. But we've got a question. Yes. Yeah. Any question? Right. Then, number 3, are the events card is black and card is spade independent? Right. First, just to remind you, if 2 events are independent, the probability of A and B will be equal to the probability of A times the probability of B. If 2 events are independent, that's the formula. This one here is the formula for 2 independent events. Okay? So, the probability of a card being black and being a spade must be equal to the probability of a card being black times the probability of a card being a spade. Okay? So I'm using the multiplication law of probabilities. So any question on independent events, you have to use the multiplication law of probability. So let's go to the intersection. The probability that a card is black and it's a spade, you can get it from the contingency table. So spade to black, that's the answer there. It will be 13 over 52, which is a quarter. Okay? So I'll put here 13 over 52. Okay, please, if you want to put a quarter there, it's fine. Okay, then the probability that the card is black, I think we got that as 26, isn't it? 26 over 52 times the probability that the card is a spade. Now, if the card is a spade, the probability is 13 over what? 52. So, this is a quarter, just to do it without any calculator. That should be 1 over 4. So, you get 1 over 4 equal to 1 over 8. Now, these two are not equal. Okay? They are not equal. Which means a card cannot be a spade and not be black. You understand what I mean? That's what this means. If a card is spade, it also has to be what? Okay, so when you're answering questions on independent events, also use common sense. Use common sense. Okay, therefore the 2 events are not independent. It means they are dependent events. Okay? They are dependent. The 2 events are not independent. Okay, please, when you answer these questions, you must write a conclusion. You must write down a conclusion. You don't just stop at the working out. You do your working out, then after the working out, you conclude. Okay, a question like this, it can be 3 marks, sometimes it can be 4 marks. A question like that. All right? Any question?